All right, here's 516162 review, section 2, number 1. It says convert each radical expression into exponential form. So 1a, we have radical form. We're going to change this into exponential form. What we know is that this inside here, we have x to the 5th, y to the 11, z to the 16th. If we're taking a fourth root of that, what that really means is I'm raising everything to the 1/4. And so basically we're going to multiply all of these exponents by 1/4 because that's the exponent property. Or really it's just dividing each thing by 4. So this is going to become x to the 5/4 if I multiply, y to the 11/4, and then z to the 16/4, or z to the 4. So final answer, x to the 5/4, y to the 11/4, and z to the 4. All right, part B. Let's write this one out. So we have negative 4x raised to the 6th. And I'm not even going to multiply any of that out yet. This is a square root. So I'm going to take this whole thing and raise it to the 1/2. Okay, so I'm just rewriting this in exponential form. If I do that, then I can take these exponents and multiply them. Right, so I have a power of a power. So I'm going to multiply this, and I'm going to have negative 4x raised to the 3. Okay, so and then we can keep on going with this. We could go ahead and simplify this down. So negative 4 cubed, right? This is negative 4 cubed times x cubed. Distribute that exponent of 3 to the terms inside. And this would reduce down to negative 64x cubed. All right, number 2. Convert each exponential expression into radical form. So now we're going the other way. So I would take this one at a time for part A. I have x to the 5/3. Remember, the bottom number is going to be the index of our radical. So because there's a 3 there, I'm going to have a cube root of x to the 5th. So I'm going to keep that 5 in there. So that would be like the first one. The second one, this would be times y, and then I have a 1/3. So this is the cube root of y. And that should be it for that first one. Well, take that back. We can go one more step here. Since they are both cube roots, we can combine those, right? So since this is a cube root and this is a cube root, we can combine those and make this into a cube root of, and we can multiply the insides. So we can say x to the 5th and y. There's our final answer. Then let's look at part B. M to the 3/4 times n to the 5/3. Do the same thing. So we'll take m to the 3/4 and write that as m cubed. Since it's divided by 4, that's really a fourth root. A fourth root of m cubed. And then same thing here. This would be a third root of n to the 5th. And now what we can't do is we cannot combine this. So we either would have to leave it like this, okay? We'd either have to leave it like this, or we'd have to do something different in the beginning of the problem. Okay, so if this was a quiz or something and you wrote it like this, probably would be like, maybe that's okay. You would at least get a bunch of the points. But really, if we wanted to combine this into one radical, which is, I'm guessing is what the answer key is going to show, is we would want to make sure, just like this one had the same denominators for their fractions, it was all divided by 3. So therefore, in the end of it, we could write this as one cube root. We can do the same thing here if we just rewrite this and find a common denominator there. So between 3/4 and 5/3, the common denominator is 12, right? So that this would become 9/12. This would become 20/12. And so we can rewrite this problem as m to the 9/12 and n to the 20/12. And the only reason why we're going to do that is just because at the end of this thing, we can write this as one radical. That's really the only reason. So now when we rewrite this, we're going to have the m. So let's write that one out. That's going to be m to the 9th, but this is now a 12th root, times n to the 20th, which is also a 12th root. Since they're both a 12 root, we can multiply these together and say this is the 12th root of m to the 9 times n to the 20th. Number 4, extract all roots and express each answer in simplest radical form. So for a, this is a square root, and we did this in previous videos. We did this in a couple different ways. Since it's a square root, what I'm going to do is take all the factors inside here, and we can think about how many perfect squares there are inside that. So for example, I have a m squared times m. Since I have m cubed, I can break that up into an m squared times m, and so this right here is one of these perfect squares. That means I'm going to be able to take one of the m's out, because that square right here is going to match up with this square right here, and I can pull one of them out. And then I'm going to go to n to the 6th. Well, basically you can divide those out, right? You know that 3 of those are going to happen. So I can take n to the 6th and say that's n squared times n squared times n squared. And then p to the 9th. So how many p to the seconds are there in p to the 9th? Well, there's going to be 4. So I'm going to write all that out. But we have one remainder. So you don't have to necessarily write out this step. I'm just, again, reminding us of the visual or the full process here. But anything that's in blue here, we're trying to figure out how many perfect squares are in there, right? So what's going to come out are all these things. So I'm going to have an m, that's going to come out, and then I'm going to have 3 n's from right here, because a square root of anything squared is just that whatever's inside. And then I'm going to have 4 p's. So 1, 2, 3, 4. So these all are coming outside of the radical. What's left over, square root, is what we haven't touched yet, which is m and p. So that'll be an m and a p. So if we make this simpler, we're going to have m n cubed p to the 4th times mp. Part B, we're going to add. Now we're going to look at, do we have like terms here? And so between this, that was a little too big. Do we have like terms? And the answer is yes, because these are the exact same thing. So I have these two like terms. We have the same thing. That means I can add these two terms together by just adding those coefficients up. So I can take 5 plus 4, and I can say, well, that's 9 times whatever that like term was, which is the cube root of x to the 9th, y to the 6th, times z. Now beyond that, since we can reduce this, I'll just put it in green. We can reduce that green part, just like we did the part A. So we're going to go ahead and do that. And so I'll do it without writing everything out here. Okay, here's how you might take this. Right, I have 9, and we ask ourselves, all right, x to the 9, how many x cubes do we have there? Well, we have 3 of them. So 3 of them are going to come outside the radical, and we're going to have an x cubed here. And there is no remainder, so there's going to be no x's stuck inside the radical. Then we're going to take the y's, and how many y's escape here? Well, we have y to the 6th. How many y cubes can I make from that? We have 2 of those. 6 divided by 3 is 2, so y to the 2 comes out evenly. And then we don't have anything for z, right? We have z to the 1, and we can't make any z cubes from that. So we're just going to go ahead and leave z inside the radical, and that's it. So this would be our final answer.